Full of Beans, an experimental archaeology project to identify the common bean, Phaseolus vulgaris, through absorbed residue in pottery. By Timothy Bauman, Eleanor Reaver, Candace Hollenbach, Sean Campagna, Kelly Santana, and Lori Robbins. Experimental Absorbed Residue Study. The goal of this experimental project is to establish a new scientific method for identifying the presence of the common bean, Phaseolus vulgaris, in the New World using absorbed residue in pottery. This is necessary because the recovery of beans in archaeological sites is rare and fragmentary from poor preservation, or the entire bean was consumed, leaving nothing behind. Examining absorbed residue in pottery may provide a new way to identify the occurrence of beans across time and space in the New World. Benome Project. This experimental study is part of the larger Benome Project, a biocultural study of the common bean in the New World at the University of Tennessee. The research objectives for this larger project are to determine when, how, and why the common bean was introduced into pre-contact indigenous foodways, to define the biochemical and genomic structure of the common bean, including ancient DNA, and to work with Native American communities in their efforts to reclaim and preserve their plant heritage. Beans in the New World. In the New World, there are more than 50 bean species, but only 5 were domesticated: the common bean, lima bean, runner bean, tepary bean, year-long bean. The common bean, Phaseolus vulgaris, is the most prolific, with 150 to 200 varieties, like the kidney, pinto, and navy. It was the only domesticated bean adopted east of the Rocky Mountains in Native American foodways before Western contact. Origins of the common bean, Phaseolus vulgaris. The common bean plant is widely adaptable to many environments and was relatively easy to domesticate. Previous research on the common bean, from both archaeological and modern samples, has concluded that there were likely 2 independent sites of domestication. The first occurred in the Peruvian Andes in South America by 2400 BC. The second was in central Mexico about 2,000 years later in the Tehuacan Valley. Arrival of the common bean to the United States. The common bean entered the U.S. through the southwest by 500 BC and did not spread over the Rocky Mountains to the plains and eastern woodlands until after AD 1100. It took a northern path through the Great Lakes and then down the Ohio River Valley, reaching the southeast U.S. after 1350 AD. Tracing how and when the common bean arrived in the eastern woodlands has been complicated by poor preservation. This experimental archaeology project is attempting to address this problem by developing a new method of identifying beans through absorbed residue in pottery. The experiment. This experimental study tried to replicate the cooking process of beans that resulted in bean residue being absorbed into an earthenware pot. Absorbed residue could then be analyzed for a biochemical signature of the common bean. If successful, this would establish a new method of discovery and provide a solution to the bean preservation problem in the archaeological record. Support for this project was provided by a 2022 Ex-Art Experimental Archaeology Award and by the University of Tennessee's McClung Museum of Natural History and Culture. The recipe and cooking process. The experiment utilized 10 pottery sherds from a broken replica Mississippian period jar with shell tempering that had never been used for cooking or storage. These sherds were divided into 2 groups of 5 that were cooked separately 3 times for a total of 12 hours in filtered water. Each cooking episode of each sherd group lasted approximately 4 hours. Group 1 was cooked with beans only to identify a bean biomarker in the residue. Group 2 was cooked with beans, corn, and deer meat to determine how the latter 2 might mask the presence of bean residue. During each hour of cooking, the sample was brought to a boil for 15 minutes at 300 degrees Fahrenheit, and then maintained at 180 degrees Fahrenheit for 45 minutes. This allowed for different absorption episodes and replicated the use of a pottery vessel over time. Ironically, the sherds provided for this experiment were done by potter Tammy Bean. After more than 30 years of research and practice, Tammy Bean is one of the foremost replicators of southeastern Indian pottery in the United States. She provided the sherds for the study from a replica Mississippian period jar, similar to the one pictured here, that she made with local clay and shell tempering but had broken. Bean selection. Of the nearly 200 common bean varieties, the Cherokee Trail of Tears bean was selected for use because of its association with the native Cherokee people from the southeast Appalachian region. Oral tradition states that this bean was carried on the Trail of Tears, which was the forced removal of the Cherokee and other southeastern native nations to the Indian Territory of Oklahoma. The Cherokee Trail of Tears bean was a pole bean, which was viney with black seeds. Its pods were about 6 inches long, and it could be eaten as a snap green, a fresh bean, or as a dry bean. If you look at the map, you can see where the Cherokee homeland is, located here between North Carolina, Georgia, and Tennessee and Alabama. The Cherokee were forced on a march across over to what we think of modern-day Oklahoma to Indian Territory. Three Sisters planting system. In the eastern woodlands, the common beans were normally grown in raised garden beds as part of the Three Sisters mixed planting system that included maize or corn, squash, and beans. The corn stalk provided a trellis for the beans to grow on, and the squash provided a thick ground cover to reduce weed growth. Corn and meat selection. The corn variety selected was the Cherokee White Eagle Dent corn because it, too, is an heirloom variety associated with the Cherokee people. White-tailed deer meat was used for this study because it was the most common terrestrial animal consumed by pre-contact native peoples in the southeastern United States. The Cherokee White Eagle Dent corn, or maize, was a blue and white corn, normally had a red cob, and it was good as cornmeal. The materials and equipment used on this project include a stainless steel induction stock pot, a stainless steel basket of sieve, a portable induction cooktop countertop burner, a drying oven, aluminum foil pouches, glass beakers, nitrile gloves, needle nose pliers, and a scale or balance. Preparing the sherds. The sherds were trimmed with a needle nose plier to approximately 5 by 6.25 centimeters in size. They were then lightly scrubbed, cleaned, and rinsed with filtered water, and then they were placed in a drying oven overnight to remove all moisture. They were then weighed, measured, and placed in a numbered aluminum pouch to prevent contamination. Sherd group number 1, cooking the sherds with beans only. This recipe included beans, 225 grams, filtered water, 2.8 liters, and 5 sherds. The beans were weighed in a glass beaker. The beans were then soaked overnight in the pot with the filtered water, and the next day 5 sherds were placed in the beans vertically and leaning against the side. Once we started the cooking process, we brought the pot to a boil at 300 degrees Fahrenheit for 15 minutes. We reduced the heat to 180 degrees Fahrenheit and cooked it for 45 minutes. Then we repeated the boil and simmer process each hour for 4 hours straight. The sherds were removed and dried overnight, and then the cooking process was repeated with new beans for a total of 3 times and 12 hours of cooking the sherds. In this slide, you'll see the before and after pictures of all the sherds from group number 1, where we cooked only with the beans. It's pretty dramatic differences. You can see the top is before and the bottom row is after with the same sherd on the same column. Pretty consistently that you see a darker stain. What you're seeing on the surface, you can see some ghosting of some of the beans. And you can see a ghosting here of a bean, another one here, another here, and so forth. But you also see some slight striations from the boiling and just the fluctuations in the water over time that are staining the surface. And what that is actually surface residue. Now, most of us, when we clean our vessels and pots at home, will scrub that away, and the same thing with Native Americans would have cleaned their pots as well. So what we're really looking for is what was not on the surface like this, but what was actually absorbed in the actual vessel itself. But these are quite good examples of surface residue, and hopefully we can see the same evidence of that residue going inside the sherd. So sherd group 2, cooking the sherds with beans, corn, and deer meat now. So the second round, we added the corn and deer meat. As I said previously, it was done to try to see how those additional ingredients may actually mask or hide our ability to see or not see the beans, or if there's a way to do that. So you say the beans and corn and deer meat were weighed on a scale or balance. The beans and corn were soaked overnight, just like the beans previously were by themselves, with filtered water. And then the next day, the deer meat was added, and 5 new sherds were placed in the pot vertically and leaning against the side of the pot as well. So overall, the ingredients for the second batch included 225 grams of beans, 150 grams of corn, 150 grams of deer meat, 2.8 liters of filtered water, and 5 sherds that were placed in the pot to cook. So similar to group 1, group 2, we brought the pot to a boil at 300 degrees Fahrenheit for 15 minutes, and then reduced the heat to 180 degrees Fahrenheit and cooked for 45 minutes. The sherds were removed and dried overnight, and then the cooking process was repeated with a new batch of beans, corn, and deer meat for a total of 3 times and 12 hours of cooking the sherds. So in this slide, we're actually looking at the comparison before and after of sherd group number 2. Again, the sherds that were cooked with the beans, maize, and deer meat. Big difference, I think, when we look at, think about the previous sherds. We don't really see any ghosting of the bean. So just on the surface residue, we don't see any just bean residue by itself for the ghosting of the beans. Instead, we're seeing cloudy, sort of a waxy texture on there. That could be the result of either the corn, or obviously the corn or deer meat that was added to it, or the fats with that. But even so, the sherds look darker. They're stained. They clearly have some surface residue, but just not as indicative of the first ones of just seeing bean shadows. And of course, that's with the new ingredients added to it. But either way, we hope that the residue and the surface treatment that we see on here from the cooking, well, some of that will actually have gotten into the vessel, that we'll be able to identify not only the bean residue, but we should be able to see the corn and deer meat as well, which those have been previously done in residue studies. After we completed the cooking of all 10 sherds, 4 of the sherds from each group were buried in the ground for 1 month. The 2 remaining sherds were placed in a freezer during the same time. This was done to examine differences in decomposition or deterioration of the bean residues that were or were not subjected to the natural environment. So in other words, we placed 8 of the sherds in the ground in order to replicate an archaeological deposit and what kind of things happen to the residues as they decompose naturally in the ground. And then we had the 2 stabilized in the freezer to see differences. Residue analysis. Residue analysis is currently being completed by my co-author, Dr. Eleanor Reber, using an HP 6890 gas chromatograph GC that is interfaced with an Agilent 5973 quadrupole mass spectrometer. This instrument separates out all the complex mixtures in the residue, the GC, and then allows for the identification of the compounds in the mixture, the MS. Both instruments are attached to a computer which runs the HP ChemStation software, helps with interpretation of the results. Results and the next steps. We're really optimistic that the forthcoming results will clearly identify bean biomarkers from the absorbed residue within the 10 pottery sherds used in this experiment. We are planning a formal publication that will be submitted to the XR journal with the results. The next step will be to test this absorbed residue method with 14th or 15th century pottery sherds from Tennessee and be able to identify bean biomarkers. Acknowledgements. We're extremely grateful for funding that we received from the 2022 XR Experimental Archaeology Award, as well as from the McClung Museum of Natural History and Culture at the University of Tennessee. A number of individuals provided support and inspiration for this project as well, including Tammy Bean, who was the potter who provided the sherds, Jefferson Chapman, the emeritus director from the McClung Museum, and the late Gary Kreitz and Bill Monahan, who both had previously done bean research and inspired me to continue with that.